In this video, we want to define some terms that we've been using kind of loosely up until this point. So you may have used terms like speed and velocity, and sometimes they seem to mean the same thing, or distance and displacement. So in this video, we're going to define all those things and be able to describe what they actually mean. The most important thing we want to do is define two terms that we'll be using over and over again throughout the course, and they are scalars and vectors. First of all, a scalar. A scalar is simply a quantity which is completely described by just giving a number, or a magnitude is the term that's used. So if I say I traveled 20 miles is a distance, that's called a scalar. Or if I say I have 5 books in my backpack, that's a scalar. Or the temperature is 20 degrees Celsius, that's a scalar. So there's just simply a number involved with it. And that's in contrast to a vector. A vector now is a quantity where you have to state two things to describe it. And the two things are both a magnitude, a number, just like the scalar, but also you have to specify a direction. Vectors are things where direction really matters. So although I could say I go 5 miles, that would be a scalar quantity called distance. But if I go 5 miles north, which as you know is different than going 5 miles south, that's a vector. If I say the wind is 15 miles an hour, that's just a number, that would be a scalar. But if I say the wind is 15 miles an hour from the northeast, that is a quantity which is called a vector because the direction matters. So if I'm an airline pilot, I don't just care what the wind speed is, I also am interested in what direction the wind comes from. So that I'm interested in is a vector, which is called velocity. So now that we've talked about scalars and vectors, let's go back and redefine some of the terms that we've been using. First, we'll define a distance. A distance is a scalar quantity, meaning it's just a number, which refers to how much ground an object has covered during its motion. For distance, we completely ignore what direction we're traveling in. It's just how far we went. So I would say the distance from my house to Lewiston Porter High School is about 28 miles. Now displacement is a vector quantity, which would refer to not only how far I go, but in what direction. It is more specifically defined as a vector quantity that measures how far and in what direction a finishing point is from a starting point. So if I said when I drive to school in the morning, I travel 28 miles due north, then the displacement between my house and Lewiston Porter High School is 28 miles to the north. To further explain the difference between distance and displacement, let's do this example question. If a physics student starts in the upper left-hand corner of the picture, so like say right there, and follows the path as shown, so they go 4 meters this way, then they go 2 meters this way, then they go 4 meters this way, and then back up 2 meters that way, and they end where they started, the question is what distance did they cover and what was their displacement? So remember, distance is just the total path length that they cover. So they went 4 meters here, and then they went 2 more meters, so now they're at 6 meters total. And then they went 4 more meters this way, so they went 10 meters total. And then they finally went this last piece, 2 more meters, so they actually covered a total distance of 12 meters. Now to decide what their displacement was, what I do is I simply compare 2 points, their starting point and their ending point. And if in this case the starting point and the ending point are the same point, there's no distance between my starting point and my ending point, then I would say that my displacement is 0, even though my distance was 12 meters. Okay, so now it's your turn to try one. In your notes, let's call this problem number 1. So I want you to try this problem, and then tomorrow you can tell me what your answer was to it. The problem says a skier, who's right here, goes from A to B. So here's A. So the skier goes all the way from A to B. And then they go to C. And then they go to D, where they end up. And the question is, there's really two questions. What is her distance that she travels when she goes from A to B to C and then D? And what's her displacement? So that's question number one. And another kind of sub-question, question 1A, does your car odometer measure distance or displacement? Let's talk about two other terms that we've kind of used back and forth, and they are speed and velocity. Speed is a scalar, meaning just a number. It measures how fast an object is moving or the rate at which an object covers distance. But it's just a number, so therefore it's a scalar. So like 35 miles an hour would be a speed. The official science definition of speed, and this again is the common sense definition that we've always thought of when we talk about speed. So speed is just distance, which is a scalar, just how far you went in how much time it took you to go that distance. So speed is a scalar and distance is a scalar. Now velocity is a vector. Velocity is the rate at which an object changes its position. Velocity is speed, but with a direction. So 35 miles an hour north is a velocity. That's a vector. 35 miles an hour is a speed. That's a scalar. So the official science definition of a velocity is it is the displacement, which is a vector, divided by the time during which that displacement takes place. So velocity is displacement with time. Speed is a distance with time. So again, to see how this works, we're going to try a problem. So I'm going to do this problem, and then you can do the next one. So the question says, if a physics student travels in the same path as they did before, but they did it in 24 seconds, we're asked two questions. What's their average speed, and what's their average velocity? So let's do average speed first. Now the average speed, so we'll just say V, average speed is distance divided by time. So the distance covered was, remember they ran around in this path. They went 4 meters and then 2 meters and then 4 meters and 2 more meters. So they went a total of 12 meters. And it says here that they did that in 24 seconds. So 12 meters in 24 seconds. So the average speed is 0.5 or 1/2 meter per second. Well, let's see now what their average velocity would be. Now, average velocity is the displacement divided by time. Unfortunately, V could represent either speed or velocity, so you kind of have to know which one you want. And D can represent either distance or displacement, so you have to really know what you want to do. But actually it turns out that this is a pretty easy problem because average velocity is the displacement divided by the time. And the displacement is the difference between where I end up and where I start. So if I start here and I run here and run here and run here and run here, if I end up where I started, then my displacement is 0. In other words, I'm not displaced. I end up right where I started. So the D there is actually going to be 0. So I am displaced 0 meters in 24 seconds. So actually my average velocity is 0. So notice here, my average speed and my average velocity are two different things. My average speed was 0.5 meter per second. My average velocity was 0. Okay, so now again it's your turn. In your notes, I would like you to call this problem number 2. And the problem is, again, the skier is going to start at A, and the skier is going to go all the way over to B, and then the skier goes to C, and then the skier goes to D. And it takes the amount of time that they show here. So here's a time, and 1 minute means that's how long it took to go from A to B. And then after 2 minutes total, it was at C, she was at C, and then after 3 minutes total, she was at D. So the question is, as she does this trip, what's the average speed and what's the average velocity? So these are elapsed total times to get to each of these locations from the start. So calculate average speed and average velocity, and then tomorrow when you come into class, show me what you got. Alright, so we've talked about distance and displacement and speed and velocity. So now we're going to talk about acceleration. Acceleration is a vector, which means acceleration has both a magnitude, in other words a number, and it has a direction. And the definition of an acceleration is the rate at which an object changes its velocity. It's the rate at which an object changes its velocity. An object is accelerating if it's changing its velocity. Now, although with velocity, there's kind of speed and velocity, which is a scalar vector pair, and there's distance and displacement, which is a scalar vector pair. There is no scalar form of acceleration. Acceleration is a pure vector. So we would write that acceleration is the change in velocity with time. And on your reference tables, this statement is written as a formula. Acceleration is equal to change in velocity with time. So now it's time for the grand finale problem. So in your notes, we're going to call this problem number 3. And the problem is, if I have a car traveling 100 miles to the east in an hour and a half, then it goes 50 miles to the west in 1 hour, we need to calculate 4 things: the distance, the displacement, the average speed, and the average velocity. So if the car goes 100 miles to the east in an hour and a half, and then 50 miles to the west in an hour, what's the distance, displacement, average speed, average velocity? So work this one out, and when you come into class tomorrow, show me what you got.